We'll assume the bomb is detonated in the air to maximize the radius of impact, as was done in Japan in 1945. But here we'll use an 800 kiloton warhead, a relatively large bomb in today's arsenals, and 100 times more powerful than the bomb dropped on Hiroshima. Upon detonation, a fireball as hot as the sun would expand to a radius of 800 meters. Those near the blast would be vaporized. And within a 2-kilometer radius, all buildings would likely be destroyed. And we'll assume that virtually no one survives inside this area, which, based on population density, would start the death tally at 120,000 people. As you move further away from ground zero, estimating deaths becomes more complicated. From as far away as 11 kilometers, the radiant heat from the blast would be strong enough to cause third-degree burns on exposed skin. And as you get closer to the blast, the heat becomes so intense that clothing, even skin, would ignite into flames. That said, most people in the city would be indoors or otherwise sheltered from direct exposure. But the very structures that offered this protection would then become a cause of injury, as debris would rip through buildings and rain down on city streets. As a rough estimate, we can assume that half the people between 2 and 11 kilometers from the blast are killed, from burns, debris, smoke, collapsed buildings, and radiation sickness, which translates roughly into an additional 500,000 people. Many of these deaths will occur days, even weeks after the attack. Radiation sickness takes about a week to cause death. And much of the dust and ash produced from the explosion will be dangerously radioactive, especially if it originated near ground zero. And the distance the particles travel will depend on the wind and other factors. Now, since this simulation is of an airburst attack, it will produce significantly less radioactive fallout than ground attacks targeting missile silos or bunkers. So we'll go with a relatively small number of deaths outside the 11-kilometer range. If it were a surface blast, the fallout deaths could surpass all other deaths combined, but it's a very difficult number to predict. In theory, radiation deaths can be reduced if people can avoid exposure to the fallout, especially during the critical first few days. Fallout shelters were common during the Cold War, but people rarely build shelters today. And schools no longer practice nuclear war drills. We generally talk less about surviving a nuclear attack. And in a way, it's good that we're less afraid of the bomb now that the Cold War is over. When nations are less on edge, the risk of accidents is arguably reduced.